In the previous examples, we use benefit-cost ratios to evaluate a single project, and this time we're going to use BC ratios to compare mutually exclusive projects. The term mutually exclusive projects is nothing fancy. It just means from a group of projects and we want just select one at most. And in the previous lectures, we have introduced comparing different projects by using the present worth, annual worth, and this time we're going to use BC method to compare the different projects. Just a recap that we cannot use BC ratios directly to compare different projects since it's not a direct measure of each project's profit potential. So selecting some project that maximizes the BC ratio does not guarantee the best project is selected. Now let's take a look at an example here. To compare different projects using BC ratios, that requires us to use the technique introduced in the class called incremental BC analysis. Now let me introduce the procedure to solve this problem. First, rank in order of increasing total equivalent worth of costs. Second, and we set that project with the lowest cost as the baseline, and we use the project with the second lowest cost to compare with that. Then we compute the incremental benefit cost ratio. If we have the BC ratio less than 1, this project, which is the second lowest cost project, is not acceptable, and we go to the next lowest cost project. Otherwise, set the current project as the baseline and go to the next lowest cost project. And then we continue this process until all the projects has been exhausted. Now let's apply the first procedure. So we reorder all the projects and rank them in ascending costs order. So we have this table. You can compare this table with the table on the left-hand side. Now we apply our second procedure. So we first check the project with the lowest cost. And here it's B, and we see that the benefit is obviously less than cost. So we will get a BC ratio for B is less than 1. And this cannot be set as baseline, so we move to the next one, that's E. And so we have E here, a benefit of E is greater than the cost of E. So this is greater than 1, and we will set as this as the baseline. Now we compute the incremental benefit cost ratio by comparing A and E. So we have delta, and that is benefit of A minus the benefit of E, and divided by the cost of A minus the cost of E, which is this guy, and then we have a minus 0.5, which is less than 1. So we conclude that project A is not acceptable. Then we continue our procedure, and this time E is still our baseline, and we have reject A, and then we want to compare C with E, and we will have this same procedure as above. And we are still computing the benefit of C minus the benefit of E divided by the cost of C minus the cost of E. Then we have this guy, which equals 1.05 greater than 1. And we are gonna say that project C is acceptable, and we set C as our new. Then here we want to compare the incremental benefit cost ratio with the last project and C, which is D and C. And we just plug in the numbers and we see this guy, which equals 0.917 or just 0.92, which is less than 1. And then we can conclude, since the incremental benefit cost ratio is less than 1, then project D is not acceptable. Then we can reach our conclusion that C is the project that I want to select. And we are done.